All right, I forgot what day I'm on, but the roof's on, plywood's on, walls are sheathed, gable's done. We also papered it this morning, dried it in for the upcoming rain. But I want to take a moment to explain how we did these rafters, how I come up with this long rafter, and be able to put it in and it fit the first time and not have to run strings or jigs or scribe stuff and all that mess. So let me get right to it. I made a little prop to explain it. To start off with, the existing garage was 26 feet long and it was on a 612 pitch. For those that don't know, what that means is most roofs are measured in similar triangles. So for every 12 inches of run, for every foot in length of the building, the roof rises 6 inches, the existing garage. So the plans had this new roof line intersecting approximately a foot back from the existing ridge line or peak. There is no ridge or trusses. So what I come up with is basically instead of 13 feet, half the building length, I came in 12, and 12 feet up 6 times. The rise was 72 inches. Okay, from where this roof is going to intersect with this, the old roof is going to intersect with the new roof. Now I had to keep in mind two things. One is the heel height for the trusses. The total heel height from the top of the wall to the top of the existing roof was 5.5 inches. The new heel height for my rafters, this is your heel height, where the rafter sits on the wall to the top of the rafter. This plumb length here, vertical line, is 7.5 on the new one. This is like a mock-up of the rafter tail. This is where it would sit on the wall, overhangs the building. We'd have a 2x6 fascia. All right, so if this building rises 5.5, excuse me, but mine 7.5, I'm already cutting into the 72 inches, 2 inches. So what I'm truly rising from the peak of my heel to the point where it intersects this roof, the true rise is 70 inches. 70 inches, and my total run is 28 feet. I got that from, again, almost half of the building was 12 feet. We came back a foot. The new addition was 16 feet. It's 28 feet. So this ratio for the new roof happens to be, for every foot, if you take 70 inches, you divide it by 28 feet, it's a 2.5 12 pitch. All right. So for every foot, it rises 2.5. So a couple ways to, and then you need to know that number to lay out these rafter tails using a speed square or framer square. You read the common rafter lengths right here. This is your pivot point. Turn it until it reads 2.5. I marked it with a pencil, and that's your plumb cut. That's how you get these vertical lines, and that would be your ridge cut if you had a ridge board, which we don't. So how do I get the length of my rafter? So this is just basic algebra. There's a couple ways. There's a couple construction calculators out there you can use, where you type in your run and your rise, and it'll give you your length of your rafter, the hypotenuse of this triangle. The old school method before I could afford a construction calculator was just a squared plus b squared equals c squared, and you'll end up with the exact same number. So there's your a squared, b squared, you add them together, you get your square root, 343 inches, 0.2. And that 0.2 is 2/10. So now you just have to convert that into an inch. Simple fraction conversion here, cross, multiply, divide. It's basically 3/16. So when we cut these rafters or set them up, from the heel, which I'd already drawn out, hooked my tape, ran all the way up, and marked 343 and 3/16. Now, Normally, this would be a plumb cut that hits a ridge line, hits a ridge board. So instead, it's laying on an existing roof. So I have this angle intersecting this angle. So how do I come up with this angle right here? So what I did is on the end of the rafter, this is the point that would be touching the roof. I'd use my speed square like I showed you a minute ago. Take it, pivot point, turn it till it reads 2.5. There's your plumb cut. So this is perfectly vertical plumb with the building, right? Now we said the existing roof was a 612, so I came down 6, 90-degree turn here off this plumb line, mark 12. Now you intersect the point where it would touch the roof to this point where the roof pitch would be. It was basically draw an intersecting line between those 2 points, and that's your rafter cut. That's your cut right here, where to lay on the roof. To start with, we didn't cut it. This actually ends up laying on what we call sleepers, 1.5 inch thick boards. So you end up cutting an extra 1.5 inch off. But to start off, we don't do that. We mark them, lay the rafter down, then you can mark your roof line, pop your lines, take your template back down, cut it, and now you have perfect marks. You know exactly where to lay these, where to install these. And after that, it's just cut, mass produce, and install.